Hello friends, today I'll share a simple program of singly linked list. Singly linked list is basically a data structure. It is a list of nodes and each node has two parts. First part is consists of the data and second part is consists of the address of the next node. The last node has address as null, so which signifies that this is the last node. Alright, let's jump into the code. So this is the structure. Okay, so yeah, the singly linked list can be represented with the help of structure. Alright, so this is the data, which is the first part, and this is the address, which is the second part. And these are some of the pointers which we will be needing in the code below. Let's go to the main function. Okay, so here we have add function, add after, append, delete all, and display. So let's see one by one. Let's see the add function. Here we are accepting some data from user and passing it to the add function. Let's go to the add function now. Okay, here is the add function. Here we got the data which user has entered. Now we are creating a temporary node here and we are initializing the data which user has specified to that node. Okay, so now this is the first case. Here, if there is no node present in the linked list, then we're gonna make the head node as the temp node which we have created right now. Okay, so the next of that head will be null because every last node's next is equals to null, but here we just have one node, so we'll make the next of that to the null. Okay, so let's say if this is not the case, we have more than 2 or 3 nodes in our linked list, then what we're gonna do is we're gonna make the next of our newly created temp is equals to head, which means the node which we have created will be placing before the head. Okay, but the first node is always head, so what we're gonna do is we're gonna make the head as the temp. Temp is the newly created node. Alright, so let's go to the add after function. Here we are accepting a number, that is a data from user, and the location after which node you want to add the new node. Okay, so this is the same, but here what we are doing is we are initializing a current pointer, that is cur, to the head, which means cur and head both are pointing to the head node, that is to the first node. Okay, so this is the condition which we discussed just now. So let's go to the else part. Here we have for loop which will iterate from 0 to the location which user has specified. Let's say user has specified a location as 2, so this loop will iterate 0 1, that is for 2 times. Alright, so here we have one more pointer, that is left, which is currently pointing to the head, to the first location. Why? Because the current is currently pointing to the first location, as head is pointing to the first location, same as left is also pointing to the first node. Alright, so let's go to here. So here we have current and left, both are pointing to the first node. Okay, so the second step is current is going to the current's next, that is current is moving to the next node. Okay, so our current has moved to the next node. Alright, then again the second iteration of for loop, current is equals to temp, that means the current which we have in here is equals to left. Okay, so both are pointing to the second node now, but in the second step current is moving to the next, that is current is moving over here. All right, now the location which user has entered is 2, so I is not less than 2. All right, so we'll go out of the loop here. Now left's next is equals to temp. Temp is the newly created node. Okay, now let's say we have a node called temp. Okay, now left's next is pointing towards the temp. Left's next is pointing towards the temp. Okay, so this is pointing towards the temp. All right, and temp's next is pointing towards the current. Okay, so how it gonna be? So it's gonna be like this. Temp's next is pointing to the cur, and whatever the data user has entered, let's say user has entered some value as 50. All right, so the picture might be not proper, but it will be in a linear format. All right, so after that append. In the append, so all these things are same again. So in this while loop we are iterating till the end of the linked list, and at the end what we are doing is we are initializing the last nodes next to the new node, that is temp, and we are making the temp as the last node over here, and after that again we are making its next to the null, which will signify that this is the last node we have. All right, let's go to the delete function. Okay, here in this function we are accepting a data from user, and the data is the node which has the data to be deleted. Okay, so again we are initializing cur to the head, that means cur and head will point to the this thing. Let's delete these things. All right, let's undo, which is more easier. Okay, so where we were, yeah, cur is equals to head over here, cur head. Okay, if the cur is equals to null, which means if there are no nodes, that means the linked list is empty. Else, while current has some nodes, so let's say cur has this node, this node, this node, so traverse all the way till the end. All right, in this while loop this condition is gonna get executed all the time, so we'll check the condition. So let's say our current pointer is pointing towards 10, and user wants to delete the node which has data 20. Okay, so in the first iteration of while loop it will check whether the data is 10, no, whether the data is 20, no, the data is 10. That means if statement will not get executed. All right, so this statement not got executed, it will go to the else statement. Else left is equals to current, current is equals to current next. Now this was the current, so it will be left and current is equals to current's next. Okay, now current is equals to current's next, so this is current. All right, again if current's data, now current's data is 20 and user wants to delete the node which has the data as 20, Yes. Now this if statement will get executed, this one. Okay, so if current is equals to head, is it head? No, head is currently here, so this if statement will not get executed, this statement will get executed. All right, now left's next is equals to current's next. Okay, this is left, this is current's next is equals to this one. Okay, so current's next is equals to this node. All right, and left's next, we are initializing now left's next to the current's next, that is to this one, and then we are doing deleting the current, that is we are freeing this thing. All right, let's delete this. All right, okay, so this is the way we have deleted that. All right, so the next function is delete all. So here what we're going to do is we're going to initialize the current to the head, and we're going to traverse all the way to the end. Okay, and again the same like what we did in here, we're gonna maintain 2 pointers, one as left and one as current, and as we move forward, as the current moves forward, we're gonna delete the previous one, like that. So we're gonna make this, so we're gonna make the left as current's next, and we're gonna free the current. Then again current we're gonna initialize to the left, again the same story. So this will we're gonna continue this thing until we get the current's next as null, and this is the way we're gonna delete the entire linked list. All right, so I hope you understand the code. If you have any comments, any suggestion, please give me. Please email me, I have mentioned my email ID, and also please visit my website www.dreamscholar.com. Thank you very much for watching this video. Thank you.